Let's take a look at solving equations using multiplication. Now, up until this point, we've been working with equations where the variable has something either added to it or subtracted to it. And to solve that, to isolate the variable, we use the opposite sign. If we had something added to it, we'd subtract that number, or if we had something subtracted from the variable, we'd add that number to cancel it out. And recall, what we do on one side, we have to do on the other side. Well, solving an equation using multiplication is actually going to work pretty much the same way. Let's take a look at an example. Let's say we have 1/2 x equals 6. Okay, so we have our variable is being multiplied by the fraction 1/2. So what we're going to do is we're going to isolate this variable by multiplying this by its reciprocal. Now, a reciprocal is just a fancy term for flipping the fraction. So to isolate x, we're going to multiply 1/2 x by 2 over 1. The reciprocal of 1 over 2 is 2 over 1. So we multiply 2 over 1 and 1/2 x. And remember, don't forget, whatever we do on one side, we have to do on the other side. So over here we have 6 times 2 over 1. Okay. Now, this will cancel with this. The 2 cancels with the 2. The 1 cancels with the 1, leaving just x on the left side. On the right side, we have 6 times 2 over 1, which is simply 2. So 6 times 2 is 12. And x equals 12 is our answer. Now, we can check this by plugging back into our original equation the value of 12 for x. And it will hold true, so we know our answer is correct. We should do this every time. And so let's take a look at another example. Let's say we have minus 3 over 5 times x equals 7 over 2. Okay, again we have our variable x being multiplied by a fraction. Now in this case it's being multiplied by a negative fraction. Now recall, we want to solve for minus x. We want x by itself. We don't want a minus x. So what we're going to do here is we're going to multiply by the reciprocal of 3 over 5, but the negative reciprocal. And I'll show you why in a second. So we have minus 5 over 3 times negative 3 over 5x. And whatever we do on one side, to keep the balance, we must do on the other side. So over here we have 7/2 times minus 5 over 3. This will cancel with this, leaving just x. Over here, we're multiplying two rational numbers. A positive and a negative will give us a negative, and we multiply numerator, and denominator with the denominator. So we have 7 times 5 is 35, and 2 times 3 is 6. So minus 35 over 6 is our answer. Now notice, if we just multiplied by the positive reciprocal, 5 over 3, we would have gotten a negative x for our variable. And we don't want that. So that would actually save us a step if we multiplied by the negative reciprocal. So let's keep that in mind. We want to solve for the positive variable, not the opposite of it. Let's do a few more of these. Let's say we have 5x divided by 2 equals minus 2. Okay, don't get excited when you see the variable in the numerator. 5x over 2 is the same thing as 5 over 2 times x. Now, I prefer to write it this way because when we're taking the reciprocal of this, we don't want to make the mistake of writing 2 over 5x. The reciprocal of 5x over 2 is 2 over 5x. Okay, we only take the reciprocal of the coefficient. We don't want to mess with the variable. So let's go ahead and, when we see the variable in the numerator, let's write it out to the side like this, just so we don't make any mistakes. So we're multiplying 5 over 2x. We're multiplying by the reciprocal 2 over 5. And we have to do the same thing on the other side. We have a minus 2 times 2 over 5. This will cancel with this, leaving just x on the left. And over here we have minus 2 times a positive 2 over 5, which gives us a negative 4 over 5. And you can check that we did this correctly by plugging in minus 4 over 5 into x in our original equation. Okay, let's look at another one. Let's do another one of these. Let's say 11x over 3 equals minus 2 over 9. Okay, again, we don't want to make any mistakes here, so let's go ahead and rewrite our first part as 11 over 3 times x equals a minus 2 over 9. Okay, so how do we isolate our variable? We're going to multiply by the reciprocal of 11 over 3. The reciprocal of 11 over 3 is 3 over 11. So 3 over 11 times 11 over 3x. Keeping the balance in the equation, we have to do it on the other side. Minus 2 over 9 times minus 3 over 11. 3 over 11 cancels with 11 over 3, leaving just x on the left side. We're multiplying two rational numbers here. A negative and a positive give us a negative. 2 times 3 is 6, and 9 times 11 is 99. Now remember, we always want to leave our answer in simplest forms when it comes to fractions. So let's pull out a factor of 3 here, which gives us a minus 2 over 33. And that's our answer. So we want to be careful when we're taking the reciprocal of a number to not mess with a variable. And let's go ahead and leave our rational numbers in simplest form. Let's see. Let's say we have a minus 3 over 8 x equals 12. Okay, we're going to multiply by the reciprocal here to get x by itself. And we want the negative reciprocal because we want to solve for a positive x, not a negative x. So we're going to multiply by minus 8 over 3. That's minus 3 over 8x. On the right side we have 12, and we're going to do the same thing over here, multiplying by minus 8 over 3. Minus 8 over 3 is going to cancel with minus 3 over 8, leaving a positive x. That's what we want. And over here we have 12 times a minus 8 over 3, which gives us a minus. 12 times 8 is 96, divided by 3. Let's go ahead and reduce it to simplest form. We can pull out a factor of 3 out of the top and bottom, give us a minus 32 over 1, or just a minus 32. So x equals minus 2 is the answer here. And we can check that by going ahead and plugging it in for our variable x in our original equation. I'll leave that up to you. Let's take a look at a couple more. Let's see, we have a minus 9x divided by 8, and that equals 1 over 7. Let's go ahead and rewrite this as a minus 9 over 8 times x, and 1 over 7 on the right side. We're just doing this so we don't make any mistakes when we're taking the reciprocal of our fraction. So we want to take the negative reciprocal, so we have a positive x on the left side. So let's multiply by a minus 8 over 9 times a minus 9 over 8x. On the right side we do the same thing. We have 1 over 7 times that negative reciprocal of minus 8 over 9. And that keeps the balance in our equation. This fraction cancels with this fraction, leaving just a positive x. Multiplying a positive rational number and a negative rational number. So we're going to have a minus. 1 times 8 is 8, and 7 times 9 is 63. So x equals a minus 8 over 63. Okay? Not a whole lot to this, but taking it one step at a time, we won't make any mistakes. All right, let's try one more. Let's say we have, let's get a different color. Let's say we have a minus x over 8 equals minus 5. Okay, here we just have a variable in the numerator, but don't get excited here. This is actually just a 1x. So we can rewrite this as a minus 1 over 8 times x, which equals minus 5. Okay, so whenever we see our variable by itself, it's an understood 1x. So we're going to multiply by the negative reciprocal. We're going to multiply by minus 8 over 1 times minus 1 over 8x. We have a minus 5 over here. This cancels with this. We're going to be left with a positive x on the left side and a minus 5. And we're actually, well, didn't fit it in here, but we're multiplying the same thing on the other side, which is a minus 8 over 1. I'm running out of room here. So a minus 5 times a minus 8 over 1 is on the right side. And this gives us a negative, and negative gives us a positive 40. 40 over 1, which is 40. So we can go ahead and plug this back in and check our answer and make sure that we got the right solution. Okay, so what do we learn here? When we have an equation with a variable being multiplied by something, we can simply isolate our variable by multiplying by the reciprocal of the number. If it's a fraction, we just simply flip the fraction, leaving the variable by itself, and we can always check our answer by plugging back into the original equation. All right, I'll see you soon.